going to focus solely on sine and cosine graphs. So we already kind of know about their parent graphs. We graphed them previously in section 4.5 when we introduced ideas of period, amplitude, and starting point. And so you can either like look back at your 4.5 notes. We have these graphs pictured. Or if you want to, real quick draw a sketch of yours, you can. Remember that for each of the parent graphs, sine and cosine, their periods are both 2 pi. And they each had amplitude of 1. And I suppose if you're looking at f of x equals cosine x and f of x equals sine x, if we wanted to go ahead and add in starting point, we would say there is no horizontal or vertical shifting, so the starting point is at 0, 0. Okay? So those are like the basic graphs. What we want to do today before we get into graphs is just kind of review domain and range, because we're going to be asked to do domain and range in our problems today, and tomorrow for your quiz you should be able to give me a domain and range. So one thing in regards to these pictures that we did in section 4.5, I had talked about how here we made a table of values. We used the quadrantal angles, 0, pi halves, pi, 3 pi halves, and 2 pi. This is how we got our picture. But I had talked about how this is a wave and it just keeps going on, right? It doesn't actually start and stop, because on the unit circle we can just go around again, go all the way to 4 pi and go all the way to 6 pi, and we're going to stop at the same values on the different quadrants. So it's just going to repeat itself. So what would you say for domain? All real numbers. And how do we write that? Negative infinity to infinity. So we're going back to our interval notations for domain and range. So negative infinity to infinity. And that's true for sine, but also cosine, right? So think about this. The input to these functions, the input, the x value, is an angle in both of those. So what it's saying is you can put in any angle. It doesn't matter where it is on the unit circle. You're always going to get a sine or a cosine. And that makes sense, because on the unit circle, sine and cosine are x and y's, and every point has to have an x and a y coordinate. So we're always going to be able to get an answer back out. Okay. What would you say for range as you look at those graphs? All real numbers? Not quite. You're constricted by the mins and maxes of the waves. What's our minimum?
-1.
-1, maximum? 1. In interval notation, what are we going to put around those? Brackets. So some of us may need to go back and review interval notation. Brackets means included. So this point right here is 3 pi halves, comma, -1. I actually get down to that location of -1, so that value needs to be included in the range. Okay. And that's true for cosine too. -1 to 1. Now, that's just domain and range for your parent graph. That doesn't apply to all sine and cosine graphs. Well, I guess domain applies to all sine and cosine graphs, right? But the range is going to change. Think about A, B, C, and D. Those parameters that we kind of worked with for amplitude, period, and starting point. In terms of range, things that can change your range, what if I take my wave and I shift it up, or I shift it down on the coordinate plane? Then I'm changing the range, right? It won't be from -1 to 1 if I move it up 5. If I move it up 5, it'll be from 4 to 6. And another thing that can affect your range would be your amplitude, because your amplitude is going to make your waves taller or shorter. So if I had an amplitude for that sine function of 3, then instead of going to 1 and -1, it would go to 3 and -3. Okay? And so that would be a new range. And imagine if I had that, and then I also shifted it up 5, then it would go from 2 to 8. So you'll be changing the range, but it should always be included in those brackets. Now, on the next slide, you don't really have to write anything down. I just kind of want you to pay attention to this visually. I'm going to give you a handout here in a minute that you're going to put into your notebook that has more information. But we've just been practicing, thank you, Leah. We've just been practicing this period, amplitude, starting point for a while. And we're going to put all of that together to help us build a graph. So we're going to use something called the framing method. I also sometimes refer to it as a window because look at this big rectangle. Imagine it like a window. And then these dotted lines are like your panes. And so you have 8 panes of glass. Okay? So you get the window effect there. And what we're going to do is we're going to plot our starting point. Okay? And from our starting point, we're going to build our frame vertically by adding an amplitude and subtracting an amplitude from the starting point. So the starting point is always going to be in the middle of the frame. Okay? And then we're going to build the frame horizontally using what we know about the period of the graph. So we always want to graph one full period. So from our starting point, we're going to build out so that this distance here is one full period. And think about, like, in terms of the 8 window panes, we have 4 different sections horizontally. This spacing needs to be even. Okay, so it's like 4 evenly grouped things that add up to the period. And then we'll just put the picture of our graph in the window. Okay. Now, I'll talk about, too, as we graph, pros, benefits, cons, negatives to this method. Okay, and there are a few negatives that we need to be aware of. Okay, so next up I'm going to pass out this little half sheet, and I'll send some tape out to the pods, so pods pass them back. I will say this is my little PSA about the tape. My rolls of tape are a little bit skinny, okay? So we need to be tape efficient today. Probably just 2 small pieces, one for the top, one for the bottom. That's all you need. You don't need to tape all the way around the blue sheet. Not necessary. Oh, good. So remember, be tape efficient. The best you can.
I think you've been holding it when you said. Oh, yeah. That's page,
Now, I know some of you are taping or waiting for tape. I am going to kind of talk through some of the blue sheets, so make sure that you're not solely focused on taping and you're kind of also listening at the same time. Notice on the screen right now, I have everything after number 3 covered up. So if you just put your hand over numbers 4 and everything below it, and you just look at the stuff at the top of that sheet, you already know everything at the top. So those 2 equations at the top, you got those A, B, C, D parameters that we talked about in 4, 5. And then 1, 2, and 3 are the same things we've been doing for what feels like forever now. Amplitude, starting point, and period. Now, I am going to say one really important thing about number 1. And I'll say this a few times. Notice it's bolded and it's underlined. You may also want to highlight, star, or circle. The starting point is for the frame, not the graph. So the frame is the window that we're looking through. Depending on the function that you're drawing, it may or may not pass through the starting point. The starting point does not have to be a point on your graph. It's a point on your frame. More on that at the bottom when we get to those other rectangles. This is also a good time to remind yourself, if you're the kind of person that needs it, you always make that same mistake. See, looks like the opposite. So I get a few people every year who just like, it's like they never get that right. And I want you to get that right. So remember, when you pull out C up here in the equations, the parameter C is preceded by a negative sign, therefore it always looks like the opposite of what it really is. Amplitude, I've already said a few times, it should always be positive when you list it for me. Please don't ever list a negative amplitude. If there is a negative, you know that your graph should be reflected. Okay, the amplitude is the absolute value of A. And then the period is 2 pi over B. Okay. Now, we're going to, in step 4, build the frame. So that's the previous slide where I said you don't have to write anything down. Just see how it all comes together. We're going to mark our starting point. Building it vertically is really easy. Just like add and subtract your amplitude and find your highest and your lowest point. Okay, so that's going to be really easy. It's the horizontal piece that's usually the toughest for students. So I have 2 methods. Now, I'll talk about these really quickly, but I'll do both of them in our examples so that you can see how both works. Sometimes one method works for a single person all the way through, and they can just always do that one method. Sometimes people know both methods. Sometimes one's easier than another. Okay, but you got to figure out what works for you. Okay, method 1. You have a starting point. And let's say my starting point, let's say I had a horizontal shift. It starts at negative pi horizontally, so I went left pi. Okay. And let's say in this example that my period is 2 pi. Okay, regular, no stretch or shrink horizontally. Okay, method 1, add the period. So negative pi plus 2 pi would be 1 pi. So that's the end, because then you have one full period in the window, negative pi to pi. Then split it in half to find the middle. So what's in the middle of negative pi and pi? 0. And then split it in half again in both sides. So what's in between negative pi and 0?
Negative pi halves.
Negative pi halves. And then over here would be positive pi halves. So you got all the labels that you need. Okay? So it's like, label the ends, find the middle, find the 2 middles. Finding the middle of 2 things is really just taking an average. Add them up, divide by 2. Sometimes for some of us that can be a challenge because it's not always nice like this. There might be fractions, but you can still add up 2 fractions and divide by 2. That would also work. Okay, method 2. Add 1/4 of the period 4 times. So let's say it's the same problem. It's a period of 2 pi, and it starts at negative pi. So 2 pi divided by 4, because it has to be evenly spaced, right? 2 pi divided by 4 is pi halves. So you just start at negative pi plus pi halves is negative pi halves. It's like negative 1 plus 1/2. Negative 1/2. There's a pi on it. And then negative pi halves plus pi halves, 0. And then 0 plus pi halves, and then pi halves plus pi halves. 1/2 pi plus 1/2 pi is 1 whole pi. And see, either way I do it, I get the same values on my horizontal. And this distance from negative pi to pi is still 2 pi. So that's really important. So I'll model that as we do our problems. And you can really try to, when you're trying to draw your own frame, pick a method that you really like. Which one do you want to try to do? I'm cool with either one. Okay, so after we get the frame, that's like the hardest part, to be real honest with you. You plot 5 critical points, sketch a graph, and then you just have to label the points. But if you've made the frame, Labeling the points is super easy. Okay. So there's 4 pictures at the bottom. In reality, if you're graphing sine and cosine like on tomorrow's quiz, there should only be 4 pictures that I see. Sine with positive A, sine with negative A, cosine with A, positive A, or cosine with a negative A. So let's talk about sine. When we graphed the parent graph of sine, remember I started with a table of values, did like the quadrantal angles. 0, pi halves, pi, 3 pi halves, 2 pi. Well, when we started, what's the sine of 0? 0, right? And so like this starting point represents what would normally be the origin if there's no shifting. So sine starts at the starting point of the frame. The starting point of the frame is the starting point of sine. And we kind of know the shape of sine. You can look back at your notes from 4-5 or look ahead if you copied those down. I was taught, and so I remember, sine is mountain high, valley low. And I just say it to myself over and over, and I'll never forget. So for sine, I got to go to the mountain top. Before you can go to valley, you have to cross the midline. So I got a mountain, and then I get a valley. So mountain high, valley low. Some people remember that because it kind of looks like an S, like a reflected, or it's just like an S shape, right? Squiggle. Okay. That's sine. What would happen if it had a negative A? Start with a valley, end with a mountain, just reflected over the horizontal axis. So we'd still start at 0, 0, but our high point would become a low point, back to the middle, high point, low point. So those are really, if you see a sine function, those are really the only 2 pictures you're allowed to draw for me. Okay. All right, when we do cosine, do you remember what happened to cosine when the angle was 0? It's equal to 1. The x-coordinate at the angle 0 is equal to 1. So this is the one that you have to be careful of. The starting point for the frame is not the starting point for cosine. Cosine starts above the starting point, at the highest point. Comes down. Do not draw a V. It is not a zigzag. I will take off. My way to remember cosine, I think, is a little bit silly, but hey, it works for me, so I don't really care. The way I remember cosine is it looks like an ice cream cone. It starts with a CO. So you can imagine my waffle cone right in there. Deliciousness. Okay, so that's a cone. And then when we do cosine with a negative A, it'll start at the lowest point. So then you could think about a cone head. You guys probably don't know about that movie, do you? Oh, you do? Okay. It's pretty terrible, isn't it? It's really ridiculous. Probably from the 90s. Okay. So I'm going to say cosine does not start at the SP. Just because you marked it a starting point doesn't mean it's the starting point on the graph. It's the starting point for really, essentially, on a coordinate plane, the origin. So what we're doing is we're shifting the axes. And when you shift the axes, cosine is already up on the axis, so it's shifted up from that point, not from the origin. Okay, and those are really the only 4 pictures for sine and cosine that you should ever draw in the little space frame. In the frame. Here's where one of our biggest negatives of the framing method is. Positives, it's pretty easy to find the critical points and figure out some exact points that are on our graph. Negative, all of our graphs look the same. Even when they're taller or shorter, or they have really long periods or really short periods, they all look the same because we're going to always draw the same size rectangle. So I'm going to talk about that too after we graph in the examples, so you can kind of like imagine what's really happening on the coordinate plane. But that's probably the biggest con to framing, is that you won't see the actual changes in the shape of the wave. You'll just know some points that are on the wave. Let's do some examples. As you're thinking ahead to tomorrow, remember we're going to go over the homework at the beginning. But we are going to take a quiz over graphing 2 questions. What I do on this slide, you need to be able to do essentially all of it. Identify period, amplitude, starting point. I really hope everybody's feeling pretty confident with that. Building the frame, that's going to be the hardest part for tomorrow. So that's why you need to practice with your homework. And then stating domain and range. So real quick, if you can, just go ahead and do period, amplitude, starting point. I'll walk around. If you got a question for me, let me know. And then I'll put up my answers here in just a moment. And I will also help you with constructing the frame the first time. So see if you can get period, amplitude, and a starting point. Okay, I got my answers up there. If you still need to write that like general form above your equation so you can pick out what's A, B, C, and D, go ahead and do that. Amplitude, you may not always show this work, the absolute value of 3. I just want everyone to be clear about where my answer is coming from, is positive 3. Period, you have to do 2 pi divided by B. Well, your B value is 1/2, so 2 pi divided by 1/2. Remember, if you're dividing by 1/2, you're really multiplying by 2. Therefore, it's 4 pi. And then because I don't have a C or a D, their value must be 0. If I had a value for C or D, I would see them there. Okay, so if nothing's there, then it's 0. All right, now we're going to do part 2, graph and label the 5 critical points. So you're just going to draw a frame. Build the window panes. I usually focus on my labeling on the vertical and the horizontal axes first, and then I draw my graph, because if I get my labeling done, the rest is so easy. So I always mark over here on the side. I put an open circle because I don't know if it's going to be on the graph or not. It depends on the graph that it is, sine or cosine. But I always mark that starting point, so that's 0, 0. Now, I usually do the vertical part first. That involves the amplitude because that's pretty easy. Remember, the amplitude is half of the distance from the min to the max. So if it's only half of the distance, I want to come to this midline where my starting point for my frame is. I'm going to add my amplitude above and subtract my amplitude below, so the actual height of my wave is 2 times the amplitude. Now, think about this. If you're adding 3 to this midline right here, are you adding it to the x or the y? You're really adding it to the y coordinate, right? Because we're talking about up and down. So 0 plus 3 is 3, and 0 minus 3 is -3. And I'll do my domain and range at the end, but essentially you now know range because you have your min and your max recorded. Okay. Now, for the horizontal spacing, this is the one that's usually a little bit trickier for people. So what I do is I go back to this starting point 0, 0, and I'm going to go ahead and label this left side down below. But remember, this is horizontal, so we're talking left or right. So we're focused on the x-coordinate of the starting point. So whatever your x-coordinate of the starting point is, that's going to come down. That's the first line right here. So that's x equals 0. Now I'm going to model both methods of labeling that horizontal axis. So here's method 1. Add the period. The period is 4 pi. 0 plus 4 pi is 4 pi. So that's the end. That would mean that horizontally I have one period of 4 pi. And now just cut it in half. What's in between 0 and 4 pi? 2 pi. And cut it in half again. What's in between 0 and 2 pi? 1 pi. And 2 pi and 4 pi? 3 pi. So like for that one's very easy. I could cut that in half all day, right? No problem. Some of them aren't quite so easy if they have fractions. So that sometimes gets people. Here's method 2. Okay, take your period, which was 4 pi, divide it by 4, and your spacing should be pi. So if I didn't have these already labeled, we'll go ahead and erase them. If I'm starting at 0, I just have to add this spacing. 0 plus pi is pi. Pi plus pi is 2 pi. 3 pi, 4 pi. Also very easy. Okay. And I get the same thing. Notice that my horizontal distance from the end to the beginning, 4 pi minus 0, is still 4 pi, which is equal to the period. Okay, anybody got any questions about building my frame there? The rest of it's pretty much just like knowing what the shapes are. So draw the correct shape. If it's cosine, I think about an ice cream cone. And so I know I'm going to start at the highest point in the frame. So notice my starting point isn't even on my graph. So then I go to the midline, low point, midline, high point. You can never go from the highest to the lowest point without going through the middle. Okay, so if you ever feel like your graph looks wonky, sometimes you've skipped the midline. Do not draw a V. Draw a cosine curve. If you need to draw more of it to make it look round, draw more of it to make it look round. Labeling the 5 critical points, super easy now that I labeled all the axes. So this x right here is 0, and this y is 3. This point is 0, 3. This point right here is pi 0. 2 pi negative 3. 3 pi 0, and 4 pi 3. So that's labeling the 5 critical points. Now those would be like 5 points that you could have generated in a table of values to help you graph the cosine. But you could imagine, like, how would we decide which x's to choose? Like, that would be really hard. So there's another benefit of the framing method, is if you just break it up, oh, here's some easy points to evaluate. Okay, and then you could graph them. Domain, I sure hope everybody gets this right on tomorrow's quiz. Negative infinity to infinity, use parentheses. What will we say for range here? Negative 3 to 3 with brackets. Awesome. Okay, now before I leave this example, I won't do this for every example, but I at least want to show you one time. Here's a visual for like the biggest con of this, or biggest negative of this method of graphing this window or framing method. Okay. So down here, I'm just going to make a small example. Okay. A coordinate plane, and like, let's say this is 2 pi. If I were to graph the parent graph of cosine, parent graph of cosine has a period of 2 pi and an amplitude of 1. So it looks something like this. If on this same coordinate plane, I plotted the 5 critical points that I just named, 0, 3, pi 0, 2 pi negative 3, 3 pi 0, and 4 pi 3. That's what that cosine graph looks like. It's much taller. It takes longer for it to complete a cycle. So like this one would complete a whole nother cycle before this one does. Okay. And we don't really ever get to like visually see that difference in our frame because you'll probably draw the same size rectangle every single time, just like me. So know that you can be thinking about that like you might want to think about, is this one taller or shorter or stretched out or shrunk in so that it does a lot of waves. Okay. The other thing you can also think about is like, where are your x and y axes? So the starting point for the frame, 0, 0, that's like the origin of the axes right here. So this is my x-axis. It's symmetric to the x-axis. And this is my y-axis. Okay, so it starts on the y-axis. But again, we don't really get to see that change in size, horizontally or vertically. Okay. Yes, Liam?
I have kind of an off-topic question.
Okay.
On the homework it says to graph them with 2 full periods. Do you want us to do 2 or just 1?
Let's do another example. No, you'll do what you do on the homework, what you do on the quiz is like what we do in class. So ignore the book directions. Okay, can you write this down and try period, amplitude, starting point? And if after you get period, amplitude, starting point, if you want to try to draw the frame and try to start labeling it, you can choose either method you want for your horizontals. I'll be coming around before I write up my answers on the board, so flag me down if you have some kind of clarifying question you want me to ask. I'm going to be looking at your cosines and make sure they're not zigzags. Practice that, you can. That looks good. I know it can be tricky with these curves. Okay, so you might take a minute just to check period amplitude starting point. Make sure that you agree with me here. Amplitude is positive 4. Period 2 pi over 2 is just pi. So now we know the wave moves faster. Okay, it's got a shorter period. And then for starting point, do not forget the C looks like the opposite in the function. So it looks like minus pi over 2, therefore it is positive pi over 2. You gotta divide it by B, which is 2. Pi over 2 divided by 2, that's like pi over 2 times 1/2. The reciprocal of 2, which is pi fourths. So you should have a starting point at positive pi fourths, comma 0. As you're building your frame, always start again with that vertical. That one shouldn't be too terrible. My amplitude is 4. Remember, you're adding that not to the x coordinate, but to the y coordinate because you're going up and down. So that's going to be 0 plus 4 is 4. 0 minus 4 is negative 4. Some people prefer at this point to label domain and range. So if you want to, domain is negative infinity to infinity. And now that you've built your frame vertically, you know it ranges from negative 4 to 4. Here's the part where you really got practice on your homework tonight, the labeling of the horizontal axis. I went ahead and brought down my x coordinate because x is horizontal, so that's the pi over 4. I'm going to do 2 methods. So I'm going to start with method 1. Method 1, add pi, your period. Well, 1/4 pi plus 1 pi is 1 1/4 pi. I should write that as an improper fraction, 5/4. So 5 pi over 4. Okay, so now I know from pi over 4 to 5 pi over 4, that's the distance of 1 pi, so I have 1 period right there. Now I have to cut it in half. What's in the middle of pi fourths and 5 pi fourths? If the pi's give you a really hard time, as long as it's all in pi, just sort of ignore it for a minute. What's in the middle of 1/4 and 5/4? 3/4. What's in the middle of 1 and 5? 3, right? As long as they have the same denominator. So that's going to be 3/4. You can also just do an average. 1/4 plus 5/4 is 6/4, which is 3/2, divided by 2 is 3/2 times 1/2, which is 3/4. Oh, pi. Sorry. And then what's in the middle of pi fourths and 3 pi fourths? 2 pi fourths, but you would write that as pi halves. And in between 3/4 pi and 5/4 pi is 4/4 pi, which is just pi. Now, if you were like, ooh, that method doesn't work so great for me right now because of all those fractions, remember that you have method 2 available. Okay. Method 2 is take your period, pi, split it up evenly between the 4 sections, so divide by 4, which is just pi fourths. Okay. You would start at this pi over 4 and then just add pi fourths. So pi over 4 plus pi over 4 is 2 pi over 4, which is pi halves. And this is really just 1/2 pi plus 1/4 pi. Well, 1/2 plus 1/4 is 3/4. I do expect you to have some ability to work with fractions, right? 3/4 pi plus 1/4 pi is another pi, gets me to pi, and then pi plus a fourth is that whole 1 1/4 again, which is 5 pi over 4. So I still get to the same thing. That was me just adding pi fourths every time. Now, make sure you draw the correct shape. The shape of this is sine. So I think about mountain high, valley low. This one gets to start at the starting point, so I get to just darken that in. Mountain high, come to my midline, valley low, back to my midline. Get a nice shape here. And then I can go through and label my points. So this is pi halves 4, 3/4 pi, comma, what am I at, 0. This is pi negative, I'm having trouble writing, pi negative 4, And this is 5 pi fourths, comma 0. Now we still have 5 minutes left, so I'm going to do one other example because I need to show you one with a D. Okay, so don't pack up. I can hear that rustling. Does anybody have any questions on that example? Okay, so I'll move through this one. You can kind of do this one with me if you like, or if you just want to kind of watch and, pay attention. It's totally up to you. So we've got y equals 3 minus cosine of x plus pi halves. Now this one would be a good one to maybe label in the beginning. We talked about this when we did 4, 5 in the beginning. What is this 3 out front? That's a d. And then it's plus a times the cosine of bx minus c. So my value of a is a -1. Okay, so be on the lookout for that. That's a d. Amplitude then would be the absolute value of -1, which is 1. There is a reflection here, so I just have to make sure I draw the right shape. My period is 2 pi over 1, which is 2 pi. And my starting point, the c value, is really -pi halves divided by b, which is 1. And then my d is 3. So that's -pi halves, comma 3. Now what I really want you to focus on this one is when you build the frame with the vertical shift. You gotta be real careful here at your starting point. It's -pi halves 3. So you started by going up 3. If your amplitude is 1, what's your max point? 4. And what's your min point? 2. So 4 and 2. Which means for my range, it's going to be 2 to 4. Just because my amplitude is 1 doesn't mean my range is -1 to 1. Okay, I have to look at it in terms of the graph. The vertical shift moved it up 3. And then it varied by 1. So it's really from 2 to 4. I'm just going to do method 2 on this one for my horizontal shifting. So I would take 2 pi, I would divide it by 4, which is pi halves. That's my spacing. -pi halves plus pi halves, 0, plus pi halves, plus pi halves, pi, plus pi halves, 3 pi halves. You can check if your spacing is right. 3 pi halves minus -pi halves is really 3 pi halves plus pi halves, which is 4 pi halves, which is 2 pi, which is my period. So that distance should be your period. And this one was a negative cosine, so I got to draw the reflected version. Okay, and then I could go through and I could, of course, label my points. In terms of your x and y axes, my y-axis is here. And my x-axis, this was up 3. This is 2, so there's 1. My x-axis must be down here. So this graph, because of that vertical shift, it's not tall enough. It doesn't even cross. It like sits above the x-axis on the coordinate plane. Okay. So just something for you to think about when you're looking at that. Your homework, like I said on that gold sheet, 4 required questions. You can do 6. Draw the frames. Label those critical points. It'll make it easier for you to check if you have the right graphs, if you have any questions at the beginning of class tomorrow. If you're feeling really overwhelmed, stop in today after school, tomorrow before school, or email me tonight. I can answer some really good questions via email. Just take pictures of your graphs and attach it to your email, okay?